has been the world's largest importer of sand for the last 20 years. However, lately, it has been harder for Singapore to obtain sand from abroad, making it a very precious resource. Hence, it is important for us to try to conserve and reduce sand usage as much as possible. In efforts of going green, our project aims to explore ways to reduce Singapore's reliance on sand in the construction industry.
We have developed 4 sustainable reinforced concrete beams made with partial replacement of natural sands by plastic powders. These plastic powders are recyclable, which means we could also reduce Singapore's high plastic waste at the same time. Polystyrene powders was used as it was found that it has the closest strength of a C40 grade concrete based on our previous testings.
This is a storeroom where materials such as coarse aggregates, fine aggregates, cement powder and PS powder are kept, and we will prepare the materials and weigh them according to our calculations. The specified amounts of materials that we prepared were handed over to a professional contractor to cast the beams. The beams were left aside to set for 28 days to reach optimum strength. Sensors were installed at the top and bottom of concrete, top and bottom of rebar, and shear links at each ends of the beams. These sensors measure the compressive and tensile stresses acting on the beams. We connected the sensors to a data logger in which we can access the data. The beams were then tested for flexure and displacement.
From our analysis and observation, all beams attained a greater shear force than shear capacity, which resulted in shear failure. The maximum load each beam can take was determined by the highest value the control machine detects before beam failure. Our results show that the concrete beam with 5% PS ratio has the strongest quality. It can withstand the highest maximum load and has the highest shear force among the other beams. However, it achieved the highest displacement, possibly due to a local effect caused by the major cracks which takes place close to the midspan.
In this project, we believe that with more research and development, the partial replacement of natural sands with plastic powders could potentially be a good alternative for sustainable concrete production.